Good morning and welcome to today. Today we're going to look at just a fun problem to start off with before I get into some right triangle trigonometry and talk to us about SOHCAHTOA. So we're going to use some calculators today. We're going to use some old-fashioned trig tables. We're going to do a little bit of everything. But I did want to take the time just to introduce, since it's such a vital part of geometry, I wanted to introduce a similar triangle shadow type problem. This is the classic problem. It appears on the SAT, the ACT. You'll probably see it on your achievement tests in a few weeks. So we're going to take us back to 6th grade when y'all went on your trip to Washington, D.C. The Washington Monument casts a shadow that is 302.5 feet. So this is the height of the Washington Monument represented by X feet. Yes, this is not drawn to scale. I am well aware of this. And this is the shadow that it casts, 302.5 feet. Jan is 5.5 feet tall, or 5.5 feet, and she casts a 3-foot shadow. To solve this type of a problem using similar triangles, we write and solve an equal proportion. So what we're looking for here is we're trying to find the height of the monument. So we could say the height of the monument is to the height of Jan, as the shadow of the monument is to the shadow of Jan. Or you could start with the smaller triangle to the bigger triangle. There are many ways you can write this. That is just one of them. So let's go ahead and compare the smaller triangle to the bigger triangle. And we're going to say Jan's height as compared to the height of the monument is equal to Jan's shadow as compared to the monument's shadow. So let's plug some numbers in and solve. So we have 5.5 over x equals 3 over 302.5. We're going to cross multiply. 3 times x equals 5.5 times 302.5. Did everybody get 1663.75? Yes? Divide each side by 3. And the height of the monument is approximately what? What did you guys get? 554.6 feet. Okay. So I like to call this type of a problem, this is just a freebie. You didn't ask for it. I just wanted to give it to you. I just wanted to share it with you. Similar triangles trying to find the height. You'll see other problems like the height of a flagpole is 40 feet. It casts a shadow of X feet. Someone standing next to the flagpole is 6 feet 2 inches and they cast a 3-foot shadow. What's the shadow cast by the flagpole? Again, similar triangles. Are there any questions? Okay, today I'd like to pick it up, and I'd like to start with something very simple and very easy. We're going to talk about right triangles and algebra. The 3 common ratios in trigonometry are the sine, the cosine, and the tangent, which are defined by the following triangle. Now, when we talk about the sine, the cosine, and the tangent, we're not going to be talking about the sine, cosine, and tangent of the right angle, but we're going to be talking about the other 2 angles, which are less than 90 degrees, or in this case, which are acute angles. Remember, an acute angle is less than 90. An obtuse angle is what? Greater than 90, but less than 180? Yes? All right. So the 3 common trigonometric ratios are sine, cosine, and tangent. Now, how did we get this little mnemonic here? SOHCAHTOA. The sine, the cosine, and the tangent. Okay, let's take a look. The sine is the measure of the leg opposite angle A over the hypotenuse. So the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So we're going to take it nice and slow. Remember, it's SOHCAHTOA. So the first letter, S, represents sine. The O represents the opposite side, and H represents the hypotenuse of the triangle. That's where we get SO from, sine opposite over hypotenuse. The cosine, that's where we get the C from, is the adjacent side over the hypotenuse. And T for tangent is the opposite side over the adjacent side. Now I'm going to explain to you how you know which sides are which. So everybody just calm down and stay with me for a couple of minutes, and you're going to see. We are talking about angle A. Does everybody understand? I just made a little arc there. That's angle A. Do you all agree with me? In a right triangle, when calling this triangle, we would say triangle ABC. The right angle is angle C. If we want to name a side of a right triangle, we name it with a lowercase letter. So the side opposite angle A, all your angles are named with capital or uppercase letters. The sign opposite angle A would be side A. The side opposite angle B would be side B. And the side opposite angle C would be side C. Ms. Urso, how do you know it's opposite? Okay, so if you're not sure, then this is what you guys can do. You can actually just take your pencil and draw a line through the angle. Where does it come out? When you draw a line through angle A, you come out on side A. When you draw a line through angle B, you come out on side B. And when you draw a line through angle C, you come out on side C. Very good. Okay, let's get rid of that mess so we don't confuse ourselves. All right. So if I want to look at angle A right now, and I want to find which side is opposite angle A. Which side is opposite angle A? Side A. Which side is the hypotenuse? Side C. And in reference to angle A, which side would you say is adjacent? Now I'm going to put a pause there and everybody listen. The word adjacent means next to or nearby. Next to or nearby. But Mrs. Urso, I see two sides that are next to or near angle A. I agree. The two sides are side B and side C. But we know something very, very important about side C. In a right triangle, this particular side here, side C, has a very special and unique job. It also has a very special name. If you know the name of side C, please raise your hand. Yes, it's the hypotenuse. So how could it have two roles? The hypotenuse is the most important job in the whole right triangle. He can't be the hypotenuse and the adjacent side both at the same time, which means by using logic and reasoning and process of elimination, then the adjacent side to angle A must be what? Side B. So if we wanted to write using letters of the sides and we wanted to find the sine of angle A, the sine of angle A, let's see which two sides we would use. We would use the opposite over the hypotenuse, which would be what, guys? A over C. Is everyone with me up to that point? Does everyone understand how I got that? Are you sure? Now, the cosine of angle A is the adjacent over the hypotenuse? Well, we all know that the hypotenuse is C. Which side did you just tell me was the adjacent side? B. And then the tangent is the opposite over the adjacent. So if you could write that for me, which two letters would you use? The opposite, yes. A over B. How many people are with me? Are you sure? Does anyone have a question? Because this would be a good place to hit pause. Ask a question. Yes?
About the other thing about the shadow casting.
I'll go back to that at the end. Is that okay?
Yeah.
Or when we're done with the video? Because really, there's nothing in the homework tonight on that. Okay. All right. So again, the sine is the opposite over the hypotenuse, which we just said was A over C. The cosine is the adjacent over the hypotenuse, which we said was B over C. And the tangent is the opposite over the adjacent, which is A over B. You all still with me? Okay. All right. Now, let's make our life a little bit interesting. Let's go ahead and find the sine, cosine, and tangent of angle B. And this time, instead of me giving you letters for the sides, I've given you numbers. Are you with me? Now, I'm going to give you in a few minutes something to look at, which is called a trigonometric table, a trig ratio table. It's actually kind of archaic, but when I went to school way back in the day, remember we didn't have calculators. We actually had to memorize. Look up here, guys. I had to memorize a lot of this, okay? And we could do it. Believe me, it wasn't that hard. So we're going to look at this, and then we're going to go ahead and kind of use both of them together just to give you an idea of what it looks like. All right, so if we want to go ahead, the first thing I would do is I would write out SOHCAHTOA every single time, knowing that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, everybody say SOHCAHTOA. Okay, everybody put your hand on your mouth and be an Indian. You just spoke Indian. That was very good. Okay, so let's go ahead, and this time, please make sure you read the directions. It's asking for the sine of angle B. So we need the opposite over the hypotenuse, which would be what? Which side is opposite angle B, guys? 9. What's the hypotenuse? Good. Let's do the cosine of angle B, and then we'll use our calculator all at the end. Adjacent over hypotenuse, which would be which side? 6 over 15. And then we have the tangent of angle B, which would be what? Opposite over adjacent. Oops, sorry, I wanted to put it with the letters. Just let me fix that for you guys. Which you guys said was 9 over 6, right? Okay, so now we're going to convert that on our calculator. Is everybody with me? Usually trig ratios are taken to 4 digits. So everybody, 9 divided by 15. And you should get 0.6. On the table, it's going to be 0.600. Are you with me? Hello?
Yeah.
I'm going to write you a note. How many decimal places? 4 decimal places. Okay. The cosine is 6 over 15. Which is, what did you guys get? Good job. And then last but not least, the tangent is 9 over 6, which is 1.5000. Are you all with me? Yes?
Yeah.
Okay, so let's make your life fun. So that was just, we found the sine, cosine, and tangent of angle B. How about if you guys find the sine, cosine, and tangent of angle A? Everybody. Find sine, cosine, tangent of angle A. Yes.
So say that the tangent is the whole number.
Yeah. You're supposed to put 4 decimal places. It's important. Okay? I'm going to make a suggestion. I wouldn't just try to do this in my head. I would actually write things out. Okay? So the sine of angle A, I would put opposite over hypotenuse, adjacent over hypotenuse for cosine, opposite over adjacent, and then fill your numbers in, guys, okay? Okay, check your answer with a friend, please. I know that in your notes they didn't round it to 4 decimal places, but that's the most correct way of doing it. Do you guys have answers for me? Yes? Okay, raise your hand if you want the sine of angle A. Who got the sine of angle A? Matt, did you get it?
No.
Sine of angle A,
6 over 15.
which equals what?
0.4000.
Good. Cosine of angle A. Go.
0.600.
Good. And the tangent of angle A? Anybody have the tangent of angle A? Somebody else. Let's go. Wake up. Thank you, Alex.
609.
Which, when you divide it, equals
0.6666.
0.666. Don't forget to round it. 0.6667. Okay. Does anybody have a question? Are you with me? Yes? Hello? All right. How can I help you?
What was the cosine?
It's right there. 0.6000. 9 over 15. You're welcome. All right. So, what? Just an easy way to remember sine, cosine, and tangent. So, sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. TOA, tangent, opposite over adjacent. Okay, so let's see again what this is all about. Again, this is just a really good depiction of what we talked about here, looking at different angles. Remember, the hypotenuse is always the slanted side, it's always the longest side, and it's always the side opposite. This is a good way to describe or to help you remember adjacent and opposite. Okay? Again, the sine, cosine, and tangent are the 3 main functions in trigonometry. They are often shortened to SIN, COS, and TAN. The calculation is simply one side of a right angle triangle divided by another. We just have to know which sides, and that's why SOHCAHTOA is so very, very helpful. Okay? All right, let me just take us to our homework. These are some other mnemonics. I think SOHCAHTOA is the easiest way to remember. I think when I went to school, we had to learn it as some old horses can always hear their owner's approach. I was like, God help me, just give me SOHCAHTOA. It's so much easier, right? So these are just, sailors often have curly auburn hair till old age. I'll pass on that one. And some old hen caught another hen taking one away. Have no idea what that means. Okay, given triangle A, B, and C. This is your homework for right now. Okay, and I know some of you are still listening online. So if you weren't here today, you don't have the worksheet, why don't you take a picture so you guys can still do the homework? Given triangle ABC below, find each of the following: the sine, cosine, and tangent of angle A. You're not doing that now. And the sine, cosine, and tangent of angle B. Are you all with me? Yes? Okay, and that's basically all I was asked to cover with you to prep you for geometry next year. Your geometry teachers are going to take it into a little deeper. We don't need to find a missing side at this point. So this concludes our lesson for today. Thank you for listening with us, and have a blessed day.